Static analysis tools find many security vulnerabilities in code. However, studies show that users are demotivated to use these tools because they report too many false warnings. One of the main reasons for this is the incomplete or wrong choice of security relevant methods that these tools use. This includes methods like sources, sinks, and sanitizers. These methods are specific to each vulnerability, and the analysts use them to match program paths that contain source to sink data flow without proper sanitization. Let's look at a static analysis tool implemented as an IntelliJ IDEA plugin that finds taint style vulnerabilities. Here we see the findings that this tool reported. There are 2,367 findings, from which 2 are related to the SQL injection vulnerability. 3 are open reader vulnerabilities, and the remaining vulnerabilities are listed. The tool also provides the source and the sink methods of each finding, which can help us to locate the problem and decide whether it is a true or false positive. As we see, the findings for the SQL injection vulnerability are false positives since we correctly use a sanitizer in line 20. However, the tool is not aware that this method is a sanitizer, so it reported the false positives. Lists of security relevant methods are carefully selected by security experts and hard-coded in most tools. The manual effort required is time-consuming, and as we see, it can be incomplete or wrong. These methods are not general, and they depend on the entire code base being analyzed, including application code and third-party libraries. Given the effort required, a more adaptable and automated solution is required. Our tool is SWAN Assist, an IntelliJ plugin that enables users to actively adapt the list of security-relevant methods directly in the IDE. SWAN Assist uses SWAN, a machine learning approach for the detection of security-relevant methods in Java libraries. It uses a manually defined list of methods as a training set. The features evaluate certain properties of the methods in the test set, which in this case is the user's codebase, and aids the classification process. Some features include information like method names and specific data flows in methods. The training set, the features, and the test set, which are the libraries being evaluated, are then used as inputs for the Vector classifier. The output would then be the security relevant methods. SWAN can be used in combination with other static analysis tools, like the one from our example. It helps the users to create a set of relevant methods required as an input for static analyses, for example taint and type state analysis. SWAN detects 4 types of methods: sources, sanitizers, sinks, and authentication methods. Methods are further categorized according to the relevant vulnerabilities, common weakness enumeration, or CWE. In the table, we see the CWEs that are supported by SWAN and that they have different definitions of the security relevant methods. For example, CWE 89, SQL injection, defines a source as a method that introduces external user input into the program. Sinks are all methods that operate and modify a database. CWE 89 has also its specific validators, which are methods that sanitize the SQL statements. SWAN Assist is an IntelliJ plugin that allows users to interact with SWAN's learning process by giving feedback on the methods of interest. The plugin helps users to manage the classification and CWE categorization of methods. The user can also rerun SWAN with the changes they have made, which helps to improve the classification of the methods. SWAN Assist has 2 target groups. On one hand, software developers using static analysis tools can directly adapt the list to their codebase and their needs, and also improve the results of the static analysis tools that they use within their IDE. On the other hand, security teams that configure static analysis tools for scanning project codebases in the build processes can use SWAN Assist to automate this process. Now let's take a look at some of the features of the plugin. The plugin can be launched by selecting the View menu, Tool windows, and then SWAN Assist. This will open the plugin's tool window. All the features of the plugin can be accessed from the editor menu by selecting the SWAN Assist menu item. However, I will focus on the workflow with the tool window. In the tool window, the features of the plugin can be accessed from the action bar, which has the following buttons. Import file. Imports the configuration file with the training set. Export file. After making changes, we can export an updated configuration file. Filter. Apply different filters to the method list. Reload SWAN. Run SWAN for the first time or rerun with an updated configuration file. Suggest methods. SWAN proposes two methods that the user should classify that are likely to have the strongest impact on SWAN's classification. Help allows the users to access online resources about the plugin. Now I'll demonstrate the tool's typical workflow using our running example. We will categorize a few methods and evaluate if SWAN correctly classifies the methods after rerunning. The plugin uses a JSON configuration file which stores details about the methods. It contains the method's fully qualified name, return type, security level, as well as the types and CWE classifications assigned to the method. After selecting the file, the method list will be populated. The methods are also marked in the editor with the corresponding icons. We can apply filters to the method list using the options from the pop-up menu. Filters that are selected have a check mark. When we want to disable a filter, we simply click on the filter. The Clear Filters option can be used to disable all selected filters. The filter options that are available include Current Class, which shows the methods that appear in the currently active file. When the active file changes, the list is updated. Type or CWE. Methods will be filtered based on the types or CWEs that are selected. Training methods shows methods used to aid the machine learning process that may be present in the configuration file. Deleted methods shows methods that were removed after rerunning SWAN. In the method list, each method has an icon that identifies its type. Sources are green, sanitizers are orange, sinks are red, and authentication methods are blue. We can also expand the method to view the CWEs that are assigned. When we double-click on a method, the class file will be opened in the editor and the method declaration will be brought in focus. When we right-click on a method, we can use the options from the pop-up menu to manage the method. The options available are Update, Restore, Delete, and Properties. When we select the Update option, a dialog appears that we can use to update the categorization for the method. The method name tooltip shows the method's fully qualified name. Using the combo box, we can select other methods that we want to update. The types and CWE fields show the categorizations that are already assigned. To assign a category, we double-click on an item from the available categories list. To remove a category, we double-click on the item in the selected category list. At least one type must be selected for a method. To manage the CWEs, we click on the CWE radio button, and we follow the same steps as before to add or remove CWEs. Assigning CWEs is not mandatory. After rerunning SWAN, some methods may no longer be categorized. This option will be available for those methods and can be used to reinstate the method. The delete option removes a method. The selected configuration file will not be affected. The export option will have to be used to get the updated list of methods. Properties. Clicking on the Properties option will load a dialog that gives us additional information, for example, discovery, comments, and other details stored in the configuration file. To add new methods, we right-click anywhere within the method declaration, select SWAN Assist from the menu, and then Add or Update method. The Add dialog, which is the same as the Update dialog, will appear with the method details populated. We can then select the types and CWEs as described before and click OK to save the method. Suggested methods. After clicking the Suggested Methods button, two methods will be generated that the user will need to classify. The dialog is the same as the Update dialog. To switch between the methods, select the method from the combo box. The methods can only be added to the list when both methods have been classified. With this feature, the user will need significantly less effort to adapt the lists compared to the random selection of methods from the code. After we have made changes to the methods, we can rerun SWAN to improve its classification. To do this, we click on the Rerun SWAN button in the action bar. In the dialog that appears, we have the option to specify the directory of the jars that we want to evaluate, the output directory, and also the location of the training jars, or we can use the default settings. A notification will appear in the event log indicating that the process has started. When the process finishes, another notification will be shown. We can then view the logs and also load the newly generated configuration file. We can now use SWAN Assist to give feedback to SWAN and make it aware of the sanitizer method and code for SQL, which the doGet method calls. We select the method and change the type to sanitizer, and the CWE category to CWE89. We can now rerun SWAN. The learning may take a few seconds, up to several minutes, and runs in a background process. In the results from our learning, we see now that the tool also learned the sanitizer and code for open redirect. This demonstrates the active learning process that users can use to adapt the list to their needs and code base. Thank you for watching.